I stopped it and restarted it. I don't know if it's actually working. I don't want it to be unlisted. Okay, but it's not allowing me to change the privacy. There we go. All my videos have been private. No wonder I haven't been getting anyone watching them. Now I feel really stupid. And I have to go to the bathroom, so I'll be right back. A real life simulation with AI. Alright, so what I was thinking is that agents do actually need to inherit a placement. Interestingly, because we're reusing variables, we will be able to call these, but we don't have to so like for example, we can do in our agent, actually don't have to put in a position type. Actually I think we do, because it could be male or female. So where is it? Unit. So instead of position type, we need to go through position type, and we need to replace them with unit type. And then we call this placement. Yeah, we'd say from placement. So placement. And then an agent and a placement have the index lambda, so we don't need that in both because where did I inherit that? I thought it was in the placement agent. Let's just do that. Cell position. Not position anymore. It's from unit for unit. Well, I thought I made that. Oh, I did it to the status. Okay. It's like I know I typed that somewhere, and the agent inherits the placement type now. We just have to say super init, and then we don't have to do any of these because they're all passed to the, I would call it the parent, but I think other people would call it the child. I would consider this the child, but I could see this being the child. But really, this would be the child because it inherits the traits of the parent. See, not all placements have energy and wealth. That's why some people would say this is the child. That would make sense to me. Status is sleeping. And then we don't have to rewrite code. So X and Y. And then we could actually do random.randint. Then we have to pass the size, the map size all the way down. So we're going to leave that. We're going to say, I almost want to put these into modules for clean code. It would be nice. I'm just not super good with Python modules. So I'm going to wait until I can focus on that. Yeah, so see, not all placements have magnitudes because only agents move. Only agents have these other factors. So let's see if we can instantiate a couple of these, and then we should be able to draw all of them because we already know the draw function works for the other types. So in this way, in society, for our population, we can append an agent that has random grid size, a cell size, and then a type. If it's not an agent, we will do random dot choice, and it would be unit dot male agent unit dot female agent. So we'll just generate random agents. Now we could bring these variables down here to the society level. I'm not against that. I just don't want to have to rewrite it if we need to do it from the engine level later. If we want logic to change on number of jobs or population, I've made this mistake before. So unit.available from unit 1 port unit. So it doesn't look like we have any bugs. We have a lot of pseudocode, which is great because these looks really simple. Simple is always better. Always better. As long as it's not too simple. Update function's almost ready. Cells, we're not changing the grid. In fact, we can get rid of the grid tab. So then for the number of jobs, we do placements with jobs, and then for the number of food, we do placement with food. And I think every language supports this. And I really like this syntax, just to say, hey, we're going to disregard this thing, we don't care about it. One thing I do want to do is just say X, Y, just for readability. And then, sex. And see, only agents have a sex. Placements do not, so A unit. Not a job, it's a work. Really should be a job, or I don't know. Anyway, no. So what we want to do is actually say jobs, food, population is none. Food, jobs, population, and then we return these. Then I'm actually going to use GPT. I'm actually going to use Hugging Face. I always forget how to do this the right way, and I always end up reading really long documentation, so this is one of those cases where I do like so this is a really cool way to do this. So we'd say populate, and say create jobs. We are going to leave so we're gonna do, we're gonna get rid of all of the selves here. We're going to put a grid size and a cell size. Then, so this is how we do it. Population, create agents. I'm gonna change this live streaming name to Creating the Matrix with AI. Deep genetic learning.
Building your online business.
We're gonna get commercials now.
Go to Wix.com.
Cool. Okay. Let's finish this. Create agents, create jobs, and I'm sure some people watch me write code and they're like, dude, you could use your GPT way more than you do, or Copilot. And then I'm sure some people are like, you shouldn't use it at all. And I've been on both sides of that argument.
Get all the tools you need. Drive more sales with customizable.
I think it's important to distinguish if you're the one coming up with the ideas or not.
Customers with a point-based loyalty program.
And I've heard both sides of the argument where people say that the whole point is to not have to come up with it yourself. But anyway, as this function is static and is no longer defined by self,
next phase of your business. Build, manage, and grow.
We're gonna get rid of self here. This is no longer a member function.
Launch your online business
Let's do self. Period, and we can get rid of these. Just get rid of them. Oh, we're still doing regex, so I grabbed the comma too. That's interesting. Okay. So we're just gonna get rid of the spaces, and then okay, we already did this on good size, cell size. We just missed that one. Good size, cell size, then. Grid size, cell size. I just realized when I used to watch videos online a lot, I'd be like, I couldn't understand like how they would mess up the way that they did. And then now that I'm on this end of it, I realize like you're hyper focused, so you look right past things that should be simple. And then there's ways to actually do this. We could do placement, random, there we go. Just create an inline iterator. And I would just copy, well, I mean, I can. Or that just consolidated all of that. And we could even consolidate it even more. create jobs equals lambda returns this. Create food equals lambda. I already got it, buddy. Save it. For me, it's more than just, I have to extend this one back out, but it's fine. Creating. It's the process of creating the logic. See, that gets a bit verbose, but all we can do is move it down here. We can add a line, and then now we can have logic pretty well cleaned out. And if we really want to, we can do something like this, and Python will ignore. And then that's a lot more compact. We see that there's patterns here. There's a difference here. It's a placement, agent, male or female, grid size. Like it's legible and easy to read. So these are technically lambdas, but we're gonna call these macros for society generation. We're gonna say Genesis. And then now our populate function takes 3 of these and we say job, food, and population, except we're not going to do that. This is where we do the multiprocessing. We want to say with pool as P. There we go. We create our jobs. But we're not going to do it like that either. We could do it like that. But we're going to do args equals let's see. We've got number of processes. Grid size and cell size. I like this way of doing it. I like the other way of doing it too because it's very literal and static, but I like this way of doing it. Like multiprocessing to me just feels like you should be considering multiple things, not linear. And this is what we're gonna do. We're gonna say that arg and then self grid size and then for argument n, then we'll do I want to try it both ways. Let's do it this way, but let's comment that out and then to benchmark this in comparison to the code below. We will leave this though. That's right. I just want to make sure. I actually want to look this up. What's the difference between the star map implementation dot apply and dot map. So, dot apply method applies to a single function and to a single set of inputs. It blocks until the result is ready. The worker becomes free, it picks it up. Map takes iterable object containing input data, apply a given function. Map distributes the workload evenly. Star map. Supports calling a function with varying numbers of arguments. Yeah, I actually do like doing it this way too. And really it should be this. Argument should be a list, and it should be for an argument for number of food, number of jobs, and number of the agents first. Agents, jobs, and food. Eventually I would like to make it to where that's how we do this. That's how we do this society simulation. Where is it at? Where's that readme at? At the number 1. Jobs provide income for some and food for others. We just simply implement a chance to trade and allow them to pick one or the other. So the vendor makes money and the buyer has food. Later, banks can let you save. Houses can let you save food you buy. So the concept is, here's the concept. Can we simulate society without telling the agent how to exist within it? Can we define rules for a society member to exist within? What sort of free agent would emerge in society? E.g., what would be varying optimal ways of scoring high? And then these are the rules. Agents require food to survive. This is agent behavior, race of agents, future implementations, etc. So jobs provide income for some and food for others. They implement a chance to trade by implementing a chance to trade and allowing them to pick one or the other, vendor or buyer. Vendor makes money, and buyer has food. Buyer gets food, so that's the rule. They exchange food for money. But we're gonna start with just a static work and a static employment. Static food source. and see if they can learn to balance the two to eat, and also figure out how close they need to be. Yeah, I think that's all we need for that one. We're gonna leave that alone. So now we got the create jobs. What I want to do is food, population, jobs, food, and then we want to say, what did it say? Star map. I could do it that way. That's probably better than creating a helper function. But it seems like people want to use the helper function. It kind of makes sense to do that for multiprocessing. And then we'll define a helper. No, that's what we're gonna do. That wouldn't work. That's not gonna work at all. We could do a tuple. We could do this. This would unwrap very easily. You know what we could do with an enum, because it's an enumeration. That's what enums are for. So we create an array, and we say function array, and then we add these functions to it. And then this becomes a double accessor. Right here we pass it in individually as an argument. No, that's not right. These are individually the arguments here. They individually get passed here to these functions. Then what we do, could create a tuple, but that's where we create the enumeration. So we have class Genesis enum, and it either becomes agents, jobs, or food. But instead we can say I'm trying to think of how to break this thing in my head, because we need to define the helper function. And our argument has to be these things. See, it wants the argument here. See if we can call this as the value. But we could redefine the enum to be these values. What we really want to do, like, this is the simplest way to do this. In Rust, you can do it like a mapping. So like a map. And you can use this like a map. And that's really what we're going to do. I mean, we're going to say, this says what we're going to do. And really what we should be mapping is the type. But they're statically mapped, so. And we can't map agents because male or female. We could pick a random choice at the top level here. And I don't exactly like the way we're choosing random integers, but we could plug in our little dictionary thing here. And this is where we implement our dictionary of placement types for society evolution. So actually we're gonna put this down here because we'll have it after this. So we'll go ahead and say evolution. And then up here we'll say Genesis. See, because we're gonna have to modify this too, because we want this to evolve. So eventually it's not gonna just be random. Yeah. So nevertheless, we will have to have this helper. Then our helper function will say the function index equal and what is n? Oh, n. Yeah, that's right. The number. Function. The function idx equals this. Then it'll be the index value, because you have to value the enum to get that. We're not worried about the name. We're using the name here so that we have a meaningful definition, but we're using the enum to map to an int because we are enumerating a number of jobs and we're enumerating a population, and this is the helper that decompiles all of this. And really this helper could be a lambda too. Always do that. But I don't feel like doing arg0 and arg1 or arg.0 or whatever. I'm not gonna do all that, so I'm gonna leave it like this actually. And we'll just, I mean, it's fine. It's not a problem. Then could do that. Or we can just return. Let me see. Yeah. Yeah, we're gonna do it like that. That's what we gotta do. But we have to zip this. That's the thing that almost I messed up. That's what makes this thing work, is that we're zipping this whole thing up. We're zipping in the arguments into this helper function, and then this helper function is a macro because it calls these functions. Like, this is the computer programming magic. This is how you build iterators. This is how you do multi-threading, multi-processing pools, queues. You build queues out of these, or middleware. Essentially, this is a generator function. So this is our main generator. And this is blocking, so I don't even want to do that. I just want this to work. And then for agent and population, we would just draw it. I have no clue if this is gonna work. If this works, I will populate twice. We have to store our jobs, food, and population here. If we did this right, this will be so fucking cool. Like, oh shit, I'm nerding out. I won't even know what to do if this works. I'm like scared to run it. This is a real thing. Yep. Cannot import name position from cell. I don't even see a position. So obviously in the wrong file. Grid.py. It's no longer a position. So the grid, this is where we need to put the logic. To do implement all major locational based update functions here. And I don't care if they're callback. Can be callbacks if necessary. We might need to remember that rule.
Listen to shockingly good podcasts on the YouTube Music app.
This thing works, I'm not gonna know what to do. Cannot import name position from cell. I didn't fix that. Placement. Oh, it's in. Had a whole bunch of stuff I didn't need everywhere. Society. Placement. Has a placement. Society had society. Hey, it loaded for a second. Unsupported types for tuple. Okay. See, I saw a way that said you could do this, but it was different. I don't know if I want to do it the way that I saw it either. I could probably do it the other way. Fine. Where am I looking? Okay, something I actually want to do is do it like this. I'm gonna do it like this and I don't care. Value is a function here because I'm making it a function by saying that Genesis is comprised of function. I'm enumerating functions. I don't care if I'm supposed to do that or not. We're gonna call this function. And we're gonna call this in. Just gonna pass them in. Can't pass them in separate, can I? Oh yeah, I can. I can do function and argument like that. I can decompile them on the way in. Duh, zip them up. Oh, I gotta do oh, it might have been right, and I just missed the last one. Fuck. Okay, doesn't matter.
Need inspiration? Shop Kroger.
Either way, it wouldn't work. Can't pickle.
Watering choices with savings beyond low prices, like digital coupons worth over $600 each
Society.
week and up to $1 off per gallon at the pump. More savings.
14
and more
pickler
informed
done. Society
flavors make
populate.
Kroger worth it every
Number
time.
of jobs.
Kroger, fresh
Zipper.
for everyone. Fuel restrictions apply.
We've
Wonder
locked
where
in
it
low
actually
prices to help
failed.
you save big store-wide. Look for the locked
We
in
could
low
call
prices tags
for
and enjoy
a
extra savings throughout the store. Kroger,
print
fresh for
args.
everyone.
That's a function. Oh, it doesn't want to pass the lambda function. That's the problem. Okay, it doesn't want to do that. But we can just just do this. We'll just pass. You might not want the lambda to be there. It's because they're lambdas? Probably still gonna complain about it being a function. Let's see if the error change can't pickle lambda. It created a normal lambda. I've listened to this one a lot. I like this one. Missing one positional argument. So that worked, I think. Cell size. I didn't need to eat them at all. That's the crazy part. Just get rid of that, but I do like it. How about we call populate, we say agent C equals, and then we'll call this one workforce employment. And then sustenance. That's great. Can't beat that. Then we get rid of the value. Just function. They all got figure, they all got good size, they all got cell size. I could decompile this and iterate it even a step further by using an iterable. But I'm not gonna do that. That's plenty efficient enough. That's what rule of programming, you can over optimize, or that wasn't an over optimization. That's making fancy code for no reason. Golfing it is what we call it. It makes it harder to read. Harder to maintain. Like, even this is more than necessary, but I want to try to squeeze some performance out of this since I'm doing it myself. I still don't understand this. Helper missing one positional argument. Cell size. Shouldn't be. Cell size, function iterable, star map chunk size. I have to look at this function. The control click. So get part of the apply result.
Need inspiration? Shop Kroger for over 30,000
This is obviously returned by async. This is great
like
documentation and
digital
code, by the
coupons
way.
for
Thank you so much.
$600 each week, and up to $1 off per gallon at the pump. More savings and more inspiring flavors.
If we can just get to this damn part. I don't understand, like, the values here. I don't understand what I'm looking at. Society calls this star map function. Oh, that's my function. I'm calling this star map. I'm calling args. So we should see. Cell size of 80, grid size of 10, argument 1, 2, 1, population of 1, is that right? Yep, 1 job and 1 food. 1 job, 1 food, 2 agents. I was wanting to keep the browser open to see if anybody watched. I don't really promote anything though. That's like... Okay, helper is missing one required positional argument. I don't think it is. I don't understand how it could be. Because these are all the same, like function. I'm not even on the right thing. I mean, it's just working. Like, this is the arguments. This is our fucking arguments. Let's print the star map. Even though it probably will fail. Helper's missing one positional argument. It can't be though, like cell size. Let's see, this is one of those times. See if GPT knows something I don't. Like maybe we need to split it back out. Maybe we don't zip it up. Can't use lambdas. I can't pickle lambdas. I had a feeling. When I first started this shit, I was like, this shit's not gonna work. I just knew it, and I could not for the life of me. I was like, nah, it'll work. I should be able to inline that, but I'm gonna leave it anyway. Was it placement? Was placement the one that broke? Placement. Locals. Well, it not let me create the index either. You're telling me I have to create a function called it lambda. It shouldn't. Bastard. That's bullshit. That's a stupid feature. That makes me want to implement lambdas for multiprocessing. I'm gonna look it up. What am I using? Multiprocessing, that's right. wish I could find who maintains this, because the fact that I'm going to fucking Reddit on my phone.
Girls with their nails done now. Girls with their nails done. I like the girls with their nails done. Girls with their girls with their nails done now. Girls with their nails done. I like the girls with their nails done.
Hey, it's James Vincent McMorrow. Check out my new song, Things We Tell Ourselves, on YouTube and YouTube Shorts, your one-stop shop for music.
And somebody told me I could.
I had a brain fart. So one of the things of the thing. We're gonna call it, whoa, I'm way off. Absolute. We're gonna call this absolute. And pass it as self. Call it. This is cool because we can get the index, and we really should actually call this the index. If I really wanted to, we could pass these back as Cartesian, but it's just as fast to type X and Y. Nevertheless. My timekeeping application helped me realize that your brain farts and you have to take breaks. So, can't pick a cool agent macro. I knew I wrote a bunch of macros. So, it won't let us write macros outside of this either. We're not going to need the magnitude inside of it though, so we can say magnitude, then later we can so we do need to define update position function, and it's just self, and then we say self.magnitude, and then so if the magnitude's less than the previous magnitude, we'll apply a reward. So self dot previous magnitude equals magnitude. Yeah, so we're always setting magnitude to the previous one. We don't want to do our own magnitude though, that's not right. Because it'll always be self. That's not right either. What the hell was I thinking? So what we need to do is target direction vector. Get rid of the magnitude. Get rid of this. Well, direction vector. I like doing the caps for the functions. Update target position. Take self target, and then we get dx equals target x minus self x, dy equals 1 target self. I'm trying to say. Then the magnitude goes in. So self previous magnitude We're gonna put this in a variable. Actually, we're just gonna get target reward. We're gonna get rid of that one. We're always just gonna go say previous magnitude equals self magnitude. And then dx dy. We're going to get the difference of x and y, and then we're going to calculate the magnitude of that difference, and then we are going to get the directional vector of that difference, and we're going to use that direction as our Q table. So we're going to base our directional choices, which way we go, based on the magnitude and direction of that magnitude. Like literally getting the direction and how far away it is. Or getting a vector. That's what a vector is. It's a direction and some magnitude. We get the directional vector. That's what it is. But we calculate our reward based on the difference of the previous magnitude and the current magnitude. So we return our current magnitude minus the previous magnitude. Then this will give us a reward. Say direction vector, then we calculate this. It's then we'll just call this function. We'll say self dot magnitude equals self dot direction vector dx dy. Then we don't even need these anymore. Just packed all this down. Oh, I got this all fucked up. That's not right. Magnitude is the square root. Oh, that's what I would do when... It doesn't make sense to do that even. We don't even need that function. Didn't do that right. Maybe look at this again. Magnitude, direction vector. Oh, we don't have that function. There we go. So that's right. Yeah. This one does need x and y. We have to turn it back in to our coordinates. This is our directional vector. So this is used for the Q table. And then this contributes to our concept reward. So we don't actually need to, in a moment, we're not storing these rewards. These rewards should be like plus or minus, and then we should just pick the best plus or minus. Whatever it is, we're just gonna pick the best rewards. And so we're gonna naturally fall into the best choices. Let's see what those best choices are. That's what the emergent behavior is. We're not actually, we are kind of, but we're not actually programming it to do anything. Target direction vector. So we're just gonna leave it direction vector. And that should be what we need to be able to move. In theory, minus the movement. Yeah, I went down that rabbit hole hard. But we had to fix that lambda, so might as well do it right. So we finally got past that. Let's see what this says. None-type object is not iterable for population. Society. Society does not. Initialize it when we initialize the engine. Let's try this because sometimes inlining things, I'm pretty sure that has nothing to do with it. Less clear. Like, that's why I think the bug is actually right here. Probably wrong about this too. But we should be telling the engine to just call Genesis, and it should be self dot populate. Okay, then we could actually call this from main. And this is probably not going to fix it either. Oh, okay. It did actually fix it. Allowed it to run. We're still missing something. So we got a none type here. So that at least helped us debug it. I can't explain how I knew that would work, but I knew it had a correlation between something not fully being initialized. Society creates its population. We're missing part of this function, so you're not returning food. I knew that when I saw that. Now we have 4 objects. We have 3 placements, 2 agents. We have 1 agent, 3 placements. It's not right though. Something is not. We're not drawing. I think I might have to take a break. There's like a tab something that I can't do and it's not open. No matter where I click, like this red dot's driving me crazy. Like another window. I knew it had to. You ever feel like you're never doing enough, but also feeling like you don't spend enough time appreciating what you have while you have it? Never doing enough, but also feeling like you don't spend time appreciating what you have while you have it. You ever feel like you're never You ever feel like you're never doing enough? You ever feel like Alright. Got distracted, but sometimes your brain farts. So I called it. I said I was going to need a mental break. I probably need a break for bed. But I need to review some documents as well. I also want to get this bug working. Get this bug fixed, rather. If I can get to a render point, I can stop. I'm gonna have to completely stop on this, though, because I've got to get my workload prioritized. This will be a future project. We're gonna call it For Real Life. And gonna have to make a Git page. It's gonna be part of my personal. Make this one public. Oh, this is part of what I can do is I can move this inside of another repo, but what I'm gonna do is just CP For Real Life into Z big the slay bigstick repos learning AI personal AI Python experimental learning. And then experimental learning is the right one, but we have to do a recursive RFPV. We don't have to do all that. That becomes recursive. It forces it, which it doesn't need to. E creates any parent folders if it needs them, or subfolders rather. And then V is verbose. So it'll show us what all it created, and there, and to create those other folders in there for us. It created For Real Life in there for us, and then I can update that later. That just backs up my stuff. Then we can go back in the project. Oh. This will be a huge project. I want to answer these questions. I mean, I don't think I can consider this complete until I can do that. Dang it. Society simulation with deep genetic learning or genetic Q based. Then we'll put the rest of this in here. Cool. And just completely distracted. So I don't understand. Let's add some prints. Let's see. We have the positions. Why are they not drawing? Go to placement and draw, and then say print, drawing self, and then let's just see. So we're not drawing these. Why not? I forget to call society draw. And run. Draw society draw. Okay. Jobs. Empty array. So because we did not initialize. Boom. So let's change the name of him. Let's just call him male, female. Let's use different terms. What are some? Let's use. I've created a hugging face agent, a model, if you will. What should we actually call male? To be more concise or descriptive. Did it break? What should we actually call male? To describe their role. To be more concise and descriptive regarding their roles in nature. No, that is not their function in nature. That is an example of their manifestation in biological terms. Dispersers and nurturers. Okay, but in asexual systems, the role of is that still the most correct term for the male and female roles or positions? We are not talking about reproduction. We are talking about their masculinity and femininity in nature and natural systems. Protector and provider, or nurturer and caregiver. Explain these roles in the terms of nature and natural processes. Okay, I want to try to fix this because I want to get the name right. Where is this at? Oh, and we generate them, right? We go to our society. It should be society, right? Male and female. We could start with the equal population of male and female, but we don't have to do that. So in our engine, in our main, we want to create the thing and then we want to run it. So when we run it, when we update, we want to update the grid. The first thing we want to do is self update agent. Agent. Society update. We want to update the society. We don't have a societal update. So we populate and we draw. That's it. But what do we do when we update? So we don't have to update jobs yet. We don't have to update food yet. We don't have to update agents yet. But we do need to create agent updates. Those don't exist yet either. When we update, we already knew we were gonna have to define update. We're gonna iterate through the queue table. We're not gonna do all that right now. We're gonna do a define move. So we can define we can say that we have class action enum left, right, up, and down. We can say direction because that is a direction. And we can change these two where left is -1, right is +1. Up would be 1 because I don't do backwards shit when doing Y, and I would consider up to be Y. C justifying -1 if forward, if you go backwards into the Z. I think of inverted logic. But we also could have no direction, so none would be 0. We also don't want to force them to zigzag, so we're gonna say up, right would be 1, 1. We'll put them together like this. Back left. The names don't matter. We're not gonna even look at them. Up left. Up right. Then back. Down right. For no reason, we're gonna do it like that. Back left is gonna be the most offset. Can't do none, so we're just gonna say here. Movement options. So each one of these could get saved. And what we're actually gonna do is I should have left these. So we're gonna say directions equals, and we're gonna put all of these in a list. And then we're gonna say here. Then we're gonna say this would be left and up, up, left. Left, back left, down, right down, back left, down, down right, right, upright, Okay. And then that makes sure that we can just make these the right order. We just let GPT do it for us. That's why we have it, is so that it could save time. Then this way we can actually map these, like literally just drop in the direction inside the directions. This would technically be a map. So that's why when people say what's the fastest way to do something, it's not the same for everyone. If we did it this way to this way, we'd want a dictionary. Because these would be keys, that's the difference. This is an index. So with an index, you use a list. You don't map with a list. You index it. But anyway, then we save these, and this becomes the value we save, not these. These are the ones we get out of it. That's when we index out of whatever value we choose. So then we have this is a function now. This is an equation. The function would be find get direction, and then it's direction. Then we would just return directions map with the direction in it. You don't have to do that. You could just do this instead. That would technically be more optimal. And since we are going to try to iterate this as fast as possible, as large as possible, every little bit counts. So we'll save this function for later. So when we move, we don't want to just add X and Y. We will say, so when we move, let's just say we don't have anything. We want to say random dot choice of, actually let's just say random choice from here. I think we can actually define this as a function, because it's still a class. And then we can say that this is a static method, and then we can say when we move, we're just going to do direction equals direction random, and then that will just give us direction. So fix one. Then we can say direction map. Actually, we'll leave that for now, and then we'll say, there we go. Yep, that's what we wanted. Now we've got X and Y, dx and dy, so this is the change that we want to make to our direction. And then, we're just going to pick a random direction. That's all we're going to do. Then we're going to say, self X, self Y. We're going to see if we can get a jitter. See if we can get this thing to work. Like if I can get it just do random shit, that's cool to me. And we can come back next time. This is gonna break state space. So that's not what I expected it to break on. Oh, okay, I see. We didn't call update. So, update, we'll just self.move. Placement has no update. Okay, so this is where we say, because this is, template. This is template code. This is the meta coding. For update, we just say pass. And I don't think we even have to pass X and Y in. Yep. So they're not jittering though. or agent update. Agent doesn't have a definition update. I think it does. It's supposed to move. And then we can just print it's not. Start at the top. Update society. It doesn't this go here? Okay. Things that update file. So it's drawing the society. Let's go back from the top. So while the thing's running, tick, we're running at 60 frames a second. By the way, events. Where are we putting? We need to do that. We're not doing anything. I want to comment that out so I know that I'm not doing anything. So I don't understand where I'm printing though. I'll draw placement. I'm printing here. So the placement is drawing. It's created from the draw function. So come on now. So drawing society. I'm still drawing society. Print that every time. But I do wonder. We're updating society. We're not calling update. That's updating the agent. Calling it. That doesn't make. Why is it not printing? Population, food, job. Population should. It's jobs, food, population. Okay, that would make a lot more sense. Boom. That shit. Okay, let's slow it down to like 15. Okay, so let's start building there. Cool. Alright, let's see if we get this to go. Okay, so the problem is we're passing. Cool that it's save that. Go to age. This say if other we're beyond the bounds. We'd have to get good good act it. Save the direction. Chosen explicit used. So we move and then we determine the magnitude. Magnitude gives us the we do need target. Chooses random direction. We'll have to integrate this with Q table. To do integrate with Q table. It's just like addicting as shit because it feels like a game by the time you come back and achieve your goals. You feel like you won something. Been on here for 3 hours and it's after midnight, and I still haven't figured out what I like completely got lost. It's doing actions, but so this is what we wanted to see. If it would stay inside. Init is missing a unit type. Cool. No, it isn't. No, it isn't. I had this problem before. What did I do? Oh. Oh, yep. It is missing a unit type. And I don't feel like looking for it, so I'm going to find it here. Here. The agent is supposed to get the cell size and the grid size. Grid size. There we go. That's not exactly right. How do we do that? On the wrong side of the map? If self dot x plus dx is greater than or equal to greater than 0 is greater than or equal to 0 because it can be 0 and is less than size, so we can say flip this around, we can say equal to less than or equal to, nope, if 0 is less than or equal to, and this is less than the size, it might have to be -1. Don't know, we'll find out. Then we'll add them. Oh, you know what? We changed size. Draw. So it's map size. So we have to use map size. Then we just say self.map size, self.map size. Okay. Boom. Hey. They do stuff and die. They don't die yet, but this is great. This is fucking great. This is awesome. Oh man, that's cool as shit. So we've got a random function now. This is so cool. This is cool as shit. So what's interesting is, so we need to figure out this logic. So when we update, we want to pick a random direction, potentially. We want to choose the best action. So when we move, we want to pass in direction. We just want to pass in a direction. That's all we want to do. We want to just pass in a direction. So for now, we're going to just choose a random direction. So we have the ability to move in a direction with some randomness. This will be cool as shit. So what we might do, percent of randomness. So what we can do too is we can say, choose the best action. So we need to look ahead at the next square based on view table. Or do a random log. So calculate collisions, calculate rewards. So I want to see if they can learn to go to work. Learn to mate. So our queue table could be we need another class. We need a table.py Then I know what I need to do next, but I am too tired to even think about it. Sure, we will leave it like that. I know that I want to Oh, that's interesting. So if they move, if their self.energy -1, if self.energy is less than 0, status equals dead. Self calculate self dot state. So define update state and update state space. That would be the last one. I don't even know what state space is. AQ table, that would I think be the last one. I think. Update the action. Already should have updated. State space. Yeah, that would be the only two left. So if self.energy is less than 0, then our status is dead. And then if our self.status was dead, we just exit. The society, when we update 4 agents, so what we're gonna do is we're gonna say population alive equals all agents are not dead. we're just gonna cheat and quick fix and add from agent status. Where is it? I like that. And not population alive. We want to print population is dead. And then we don't want to do that yet. That is a good idea. I'm gonna just turn. So we're not getting to a dead state. That's why I did that like that. So let's say we should only hit this if all the agents are dead. They're not dead, they're hanging. When we draw an agent, we draw an emplacement. So agent has status. Placement has a status, but we want to say that the status is the unit type. But we want to convert it to a string specifically. We want it to specifically be a string. And then are going to get why are they sleeping? Work is unit type. Food is unit type. Why are they sleeping? So the agents are going to sleep. Why? Let's just say they're all hungry. That shouldn't make a difference, though. This is a lab. I don't understand why it's... It's still draw. Oh, I'm getting tired. I don't want to set the energy to be 50 at first and the wealth to be 25. Everyone should have some money. Maybe we start with like 75, 25 money. See how far they can travel. Yeah. Fine, calculate. I'm gonna say, reward equals 0, and reward plus equals get target reward. So what we're gonna need to do, implement a way to find the next target. And so we're just gonna let them like randomly choose things and then see if they gravitate towards certain decisions. They should. If we can do that, then we've built a machine learning agent. So tired. I guess I could get off here now. What I was gonna do though, I do want to put this on there. Damn it. Target. Target. So we self.target. So class target. Dude. No. Work. And then class action. Move, eat, work, sleep, mate, harvest. I do like harvest. Could grow this out into harvesting type. Grow this out into seeking a mate and or sex and or mate. Found something like that. Even this is more than I want to get into right now because each one of these becomes their own class, which is why we are going to have to set up modules. This is going to grow into a really big project, but I'm trying to keep it all really simple. Like, I don't want these to be hundreds of lines like it already is. But yeah, let's just see if we can get the target reward. Self. Let's do another one. Self.target equals choose random target. So that target should have an X and a Y. So for us to, we'll have to say find target. We'll pass a function in. We will say find target and we will do a random target. If self target is none, otherwise go for that target. Initialize it as 9. And then we call this update function society. Society wants to have find target. It's actually a callback function. Get target. Not. God. Get target. Self.targeting. Self-target. Let's add some documents. This has to be for the move to ensure the target cannot choose an sequence from random. Random choice for agent 20. Yeah, we're not. What we will do is we will just say self. No, we can't. It won't be those two, so we're to do implement the date. Self choose random. Okay, where we get good. Fine. Target. But yeah, we want this to be needs to be as random as possible to explore all possible. This is how gradient descent works. And then we put an if statement here. If, yeah. So move. So the problem is that the target is just a target. It doesn't actually have lookup table or anything. And I'm too tired to think that far into this. The fact that we have a random function, so we can go to move as well. The direction will have to be set. Direction. Value, we'll have to calculate the value. Calculate the direction. So we do want these things to know which direction they're in. Target X Y, so we get the target reward. So we actually need to calculate direction vector. Yeah, I knew we needed to do this earlier and I got distracted. Calculate direction self and target. And see, this is where bias comes in, and we have to really consider this contributes to our concept of reward based on magnitude. So we reward good magnitude based on dx and dy. Dx and dy come from target. So we need to make sure this passes in dx and dy. Alright, so when we calculate the direction, you know what we have to do? That magnitude. This is what messed me up earlier. And then we have to say target direction vector, and then we have to return this is direction, and this is the intensity of that direction. What a vector is actually. So then we say self target direction vector, and because this is the one that we store. So we will have a target. We still have to pass in the target though. So what we're doing here too, there's another calculation that we're doing in here that's very subtle. When we pass the magnitude to the previous magnitude, and then we check, and when we subtract here, we are calculating the difference of that magnitude. So we're actually scoring a movement. The problem is here that when we call get target reward, we're actually setting those values. So what we want to do, I'm gonna write one more function, reward vector. So get find get target reward. And we're gonna work on this first one, and then I'm gonna call it a quitter. Target reward. Oh yeah, this is not to get the target reward. This is get total reward. So this basically gonna do pseudocode. We're gonna iterate through all possible this is where we're gonna pass in total reward. This actually needs to comes after. No, we can't be. This is where I always get messed up. It has to come afterwards. So we're already getting target reward. Oh, I see. We do have a potential for left, right, up, and down. We will have to abstract these out again though, because this is just a random function. We actually need to choose the best of them and not like, when do we choose another one? We have to let this thing define its own random behaviors. God, I could just keep working on this until the sun came up and then be dead tomorrow, but I can't do that. So if the distance is towards the target is less, we still have to figure out what our target is. So we choose a random action, we choose a target. If there's not one, let's move this out. If the target is none, and target, find target. Nope. Nope. Oh, when we find the target, when we call update, we find the target. Oh, that actually worked. I'm so tired, I don't even know what I did to implement that. Oh, wow. So I don't know what we even did here. There's no attribute direction. Do not direction. So when we choose chosen direction, that's the problem. Oh, direction. Chosen direction. Target. Get target word. Get target word. Target. As in the target here too. For now, we want to calculate it with our target that we chose, but we want to be able to enter the potential target. So target. Calculate. Oh, to return. Uh, Yep. If status is eating up to. So we have to calculate reward. We need to calculate target and status. Got to get rid of all of the selves here. Reward. Self target. Self status. So we have to, because we couldn't have to create a potential get target reward. Team doesn't have additional target. Oh. Object is an attribute X. Target X. Choose a target. Yeah. Alt equals fine. To move this outside of the if that will be my own target. Cannot local variable max or is not. Could do is pass x, y, dx, dy, x, y, dx, dy, and then we just calculate y here. Really could calculate that in the offset as well, but we're already doing it here. Could inline this whole equation, so we won't use it outside of this. I do like the magnitude function being there like that though. I do like taking things like this here. These give us utility function. All that. Vector. Magnitude. Vector is a magnitude vector. So literally what it is a vector. Let me just call this vector magnitude. And we actually just say we have to have that one there. But return mag as well. Unless we move this one. So if we have we made vector also return the magnitude. We just return the vector with the magnitude. Look at that. And we can get the rewards based on a target. So we calculate x and y, and then self dot x and self dot y. This also goes up here. Good integration. Sometimes I'm like, I actually feel really good about what I'm doing. Calculate reward. This is the calculate reward function now because we abstract we don't update the target to say target and magnitude. And we return magnitude and target direction vector. And if we wanted to be really petty, we could pass in that equation and move it over there, and then we might as well move that over there too. The only other thing we could do is move all of this back into here and inline the entire thing, but this is sufficient. I mean, we can use these other places, so that's why we might want to say like calculate direction. I mean, it's kind of stupid because you need. It almost seems like this wouldn't work because you need this part. You have to have the dx and dy. So that really actually makes sense to put target x and y here. Target x, target y. And calculate this X, Y, and calculate those here. There it is, self. Calculate. This is not how you're supposed to do these functions. You're actually supposed to do them like here, I think. We'll do it right. Get forward. Let's calculate forward, and we want to say what is actually calculate target. So actually explicit. Actually float. A target fraction vector. Word. Dictionary like target reward. There we go. I think this equation is too simple. So the problem is if we divide by 0, so none of these can be 0. So if either of these equals 0, we're just going to return nothing. Calculate reward is no longer, we are building this thing. I did not want to do this tonight. Target. chosen target direction. Can't wait to split up these functions into groups. Oh, it's reward object, and then that would be reward object reward. Is that right? They're still going all over the place, and I don't know what status is going to be on the front, and I'm not going to do anything about it. Well, it is cool. They are doing stuff. It's because we're just choosing a random direction once. If we put this here, for example, we'll just keep jittering, and that's fine. Our population dies. This is a great stopping point. Appreciate everybody or anybody who's watched. Building a whole new method, that's right. Alright, everybody, I appreciate you all for chilling and tuning in and watching. 4.5 hours. Y'all, this is only a drop in the bucket. You guys have no clue how much I miss my kids every day, even when I'm with them.